So whether a service is written in Java or in a simple method, it will typically talk to the entity engine to get information from and send information to the database. The entity engine has an entity model XML file where the entities are defined. An entity corresponds to a table in the database and a field to a column. And there are relationships defined between the entities so that the entity engine can compare its metadata to the metadata in the database and tell you about any differences. It can optionally automatically create any missing tables or columns, and likewise with primary keys, foreign keys, and so on, indexes and so on. And it can tell you if any are defined or that are not in the database or that are different from what is defined in the database. On an operational level, from the Java methods or simple methods that are interacting with the database, or screen actions even that are interacting with the database, basically it tells it to do an operation like a find by primary key, for example. The entity engine looks at the definition for the entity in question that the operation is to be done on and generates the SQL based on that. And then using the configuration in the entity engine.xml file, it will see which data source or database that it needs to talk to. It uses the JDBC API to send that information down there, get the results back, and package them in some other helpful objects that are part of the entity engine API. That we call a generic value object. It implements the map interface, so when coming back and being used in an FTL template or a form or as part of a simple method, we can just treat it as a normal map. So you'll see here one of the big differences between the Open for Business framework and traditional Java enterprise architectures is that these tools make no attempt to be object-oriented for the business logic. They are, of course, themselves implemented taking advantage of the features of the object-oriented Java language, but they themselves do not attempt to do a mapping between the relational data model and an object model. And so we use the relational data model from bottom to top and avoid the mapping code, which is generally highly redundant and in some cases error-prone. And if any mapping is done, or if there are any differences between the object model and the entity model, those can be a significant amount of work to maintain. So we've simply eliminated that as part of the design of the OFBiz architecture. So as we'll see in some examples, this makes it very nice to work with. Another nice thing about these tools that are written to work together is entity definitions can be reused in higher level artifacts, as can service definitions and so on. For example, usually in the service definition, if it is being used if the service purpose is to do a lower level operation, like a CRUD operation, create, update, or delete, on a particular entity, then the definition of the service will be derived from the definition of the entity, and the fields will automatically be mapped into service definition attributes. The same thing is true for the form widget. Typically, a form will be used to gather information that is sent to the server in a request processed by an event, which is implemented as a service. So the input from a form will be processed by some sort of service. So the form definition for displaying the form can be derived from the service definition, automatically creating form fields that are based on these service attributes. So there's a high-level overview of the different artifacts to be used in when creating applications or parts of applications using the OFBiz framework. Now there are different parts here where I've noted the secondary best practice tools like Bean Shell, FreeMarker, and Java methods for implementing services. In the code we're about to see, you will see only the best practices tools used. So this will include the controller.xml file, screen definition XML files, form definition XML files, service definition XML files, service implementations using the simple method mini language in these services.xml files. We'll see the entity model.xml files with the entity definitions. There, you can of course plug in other tools at different points, and you'll see places like the actions here, the events here, the view definitions here, service implementations, where you can plug in really any tool that you want. In fact, even lower level entity database interactions can go directly through JDBC talking to the database when you're writing them in Java, rather than going through the entity engine. So there are lower level alternatives for all of these things, and they are designed to interact with them. So as long as your persistence mechanism supports the JTA transaction management API, then it can coexist even in the same transaction with entity engine calls. So this kind of will give you a high-level picture of how these different pieces fit together and what they are used for. Now we'll go look at the details of these different things, and you'll start seeing more and more how we can take these higher level artifacts that are closer to design artifacts to implement applications.